a repository of actually NDLI is a virtually a repository of learning resources, and it contains a vast collection of books, lectures, simulations, etc. And it is accessible to all those who register in this program. This project is under Ministry of Education under Government of India, and it is managed through National Mission of Education through Information and Communication Technology, also known as NMEIC. This whole project of NDLI is developed, operated, and maintained by IIT Kharagpur. The purpose of this NDLI is to provide free access of books to all its users, and already it has registered more than 2 million users. So today on this topic of mitigation of earthquake damages to structures in Northeast region, the main presentation will be given by Dr. H.K. Borua sir, also known as Dr. Hemakanto Borua sir. So he is basically the Director of Academic Affairs in RIST, and he is associated with this institute since 2010. Sir has completed his PhD in 1976 from IIT Kharagpur. His topic of PhD was lateral stability of frames infilled with walls. He has many national and international publications, and he has also attended many conferences, and he has been a participant of many important affairs nationally and internationally. Some of his the conferences which he has attended are 80th World Conference of Earthquake Engineering, which was held in New Delhi in 1977, and building science in Great Britain. These are some of the conferences that he has attended, and he has also participated in many UN sponsored conferences, and he was also a member of Indian delegation during his visit to Germany for energy efficient building.
Respected Principal Dr. Pathak, my dear faculty members and the students present, and I have been told that many are attending online. Good morning to you all. My presentation is on the topic mitigation of earthquake damages to structures in Northeast region. I will start the presentation with a few photographs. These are the representative photographs of the structures damaged in some of the past earthquakes. The first one, as you see there, this is a bridge which was damaged in 8.6 magnitude earthquake of 1950. I will not discuss the reasons for which this bridge has got damaged. Just I am showing as a representative damages to structures. Next one, as you see, this is a 6.7 magnitude earthquake of 2016, which caused damages in Manipur. There are thousands of pictures. I picked up this one just to show you the extent of damages which can be caused by an earthquake of even a 6.7 degree magnitude earthquake. The next one, you see, this is a structure damaged by the 6.4 magnitude earthquake of 2021 in Assam. There are thousands of figures which we have even in internet available. As evidenced by the photographs of structures shown, see, many structures in northeastern region are vulnerable to earthquake damages, even under moderate to strong earthquakes. See here, when I talk about moderate to strong earthquake, what is the definition of a moderate earthquake? In the slides I have shown there below, see, this is 5 to 5.9 magnitude is called a moderate earthquake, and 6 to 6.9 is called a strong one, and 7 to 7.9 a major one, and 8 and above is called a great earthquake. So here, see, in Assam, in the 20th century, 21st century, we have only one great earthquake, that is 1950. And after that, we had number of earthquakes. Most of them were strong and moderate. But even under the moderate earthquakes, we have got the structural damages to a great extent. And this tells me that in northeastern regions, there are hundreds of structures which are vulnerable, not to speak of great earthquake. Even moderate and strong earthquakes, we have the damages. And we all know the extent of loss of life and property we had in these earthquakes. See, in keeping with the objective of Yokohama Strategy of Safe World adopted at the UN-sponsored conference of 1994, all earthquake-prone countries in the world are now engaged in adoption of the proactive measures. Now here I would like to state, what is proactive measures? See, there are two types of measures to be taken for the mitigation of earthquake damages. One is called the proactive measures. Proactive measures mean the measures to be taken before the occurrence of earthquake. And we have got to take a lot of measures even after the occurrence of an earthquake. So I will not deal with the post-disaster preparedness or measures to be taken. I will be dealing with only the proactive measures to be taken for structures. And here I would like to state the other point, why the adoption of the proactive measures has become so important. Even today, we are not in a position to predict the earthquake with reference to date, time, and specific location. So the only way left is to go for the adoption of proactive measures. Here, there is another point I should talk about. See, since prediction is not there, but there is another aspect which has been developed now. I think that will come. If it doesn't come, I'll tell you later at the end. Now, major areas of deficiencies. So we have a lot of vulnerable structures in the region. I'll give you an idea. See, recently, during the last 2 years, I was associated with one World Bank project. The project was involved in preparing the DPR of the vulnerable structures in Assam. So there an assessment was made. As per that assessment, more than 700 public buildings only, not to speak of the private buildings, were identified as vulnerable buildings in Assam. So think of the number of vulnerable buildings in the whole region of Northeast. In Assam itself, as identified recently, more than 700 vulnerable public buildings are there. And think of the numbers in the private sector. That is not studied yet. But for the public buildings, it was identified that more than 700 public buildings are vulnerable to earthquake. So the major areas for deficiencies reflect that, see, all competent persons have studied the regions, structural regions, which has led to the damages of the structures, damaged by the past earthquakes. So there, that study has reflected very well number of areas in which these structures are deficient. Those areas are deficiencies in planning, deficiencies in design, deficiencies in detailing, deficiencies in quality control during construction, and deficiencies in maintenance. So these are the major areas. I will not deal with the detailed aspects of these areas. that is, I have kept it out of the scope of this presentation. So these are the major areas. A general question raised, a general question was raised after the Gujarat earthquake. So the question was, many people asked, why technology is developing so much? The question was this: has the technology failed us? That was the general question asked. The answer to this question is no. Technology has not failed. It is something else that has failed us, and that has led to the collapse of so many structures. This I have given briefly the reason, because many structures close to the why technology has not failed, that is substantiated by this. Say this is one building damaged by earthquake, and just by that there is another building which has been properly engineered and designed and constructed that has not shown any damages. So what does it say? Based on that, it is concluded, because many of the structures close to the ones damaged survive. That is the reason for which we say technology has not failed us. It is truly the failure on our part. I strongly feel this. It is truly the failure on our part to utilize the technology made available to us by the courts of cases, along with different explanatory handbooks as published by our organization, which is called the Bureau of Indian Standards. Mitigation measures which are now being practiced all over the world internationally. These measures include broadly two types: proactive measures for new structures and proactive measures for old structures. So I'll be briefly dealing with these two types of structures, namely the new structures and the existing structures. What are the possible proactive measures which we have to take? Mitigation measures for new structures. So I'll be dealing with first the new structures. Mitigation for new structures. New structures means which we are going to construct now. The areas to be taken into account are: firstly, proper planning; secondly, proper structural design; thirdly, proper detailing of the structural elements; and lastly, proper construction with quality control. While performing these tasks, since students are there, I have noted this point. While performing these tasks, the basic concepts of structural engineering and the provisions of the codes of practices have to be duly honored. In addition to the above noted areas, there are different guidelines given by different bodies who control the construction activities. So those guidelines have also to be duly respected. Broad guidelines given by the Government of India. So for the proactive measures to be taken for new structures, the Government of India has given a broad guideline. The Ministry of Urban Development, Government of India, issued a notification in 2021 March, immediately after the occurrence of the Gujarat earthquake. And I have taken only the main 3 points from that notification. The first one is, each building constructed in urban areas shall be structurally designed by a registered professional engineer who shall be designated as structural engineer. The point is, the structural design of a building having more than 10 floors shall be proof checked by a professional engineer. selected out of a panel approved by the city authorities. And third one, construction of each building in urban areas shall be supervised by a professional engineer who will certify that the building has been constructed and quality has been maintained as per the design drawings and as per the quality that is conceived in the design. So these are the main 3 points. See, these 3 points I have taken with the purpose of emphasizing the fact that these budding civil engineers have to understand the role they will have to play in professional life. Example showing lack of basic structural concepts in new structures. So I'll show you in my next slides, 2 slides. One, see the public building for SIVASAGAR. SIVASAGAR is a place in the Upper Assam. This NATYA Mandir. And second one is a building of Dibrugarh University. These 2 buildings I have chosen. These are new buildings constructed, and during construction period, some damages has occurred. And I was the person called for looking into that and advise what should be done. So these are my real cases I have to deal with in my professional life. So I'll deal with this one. The first one, see, as you see in the slide, there is a beam. A simple case. But this beam is very important. Why? It has a very long span, as big as 16.5, around 60 feet. And this carries a lot of load because this is a beam meant for a balcony of the auditorium hall in the ground floor of that 3-story building. So it was, the owner didn't, owner means the owner was the committee of this NATYA Samaj. There is a Samaj, there is a committee which was constituted for taking looking after the construction. So there are a lot of top class people involved in the committee. They didn't make any mistake, committee as such. They engaged a proper competent designer for design, and for construction, they engaged proper engineers. There are 2 engineers. One was retired SDO from PW, young graduate from JC. So the committee didn't make any mistake. They took all care. So it was designed, and this beam was cast. After the building was complete, balcony was taken up at the later stage. So this was cast, and at the end of 28 days, they removed the shuttering. As soon as the shuttering was removed, as you see, I have shown by black spot here in the second figure, deflection occurred and crack developed, as you see those in the middle part. Then immediately they took care and gave support and brought jacks and all this and kept in position. Then they wanted to go for investigation. Then eventually, I'll make a shortcut. Details I told Dr. Prasad. The shortcut, eventually I was there. So when I saw, I asked the committee to show me the design drawings. I saw the design drawings and I just immediately reacted. This design is wrong. Here, I want to emphasize the points on what basis I have told the design is wrong. The first basis, by seeing the design, you know, there is a code provision, which is the consideration of the deflection. We call it, we design a beam for 2 things. One, limit state of collapse in flexure, and other one is limit state of serviceability. So I get the comment straight away on the basis of the limit state of serviceability. I didn't look into the other aspect. So by seeing the I knew that the limit state of serviceability is not satisfied. Why not satisfied? By seeing the depth, I knew that the span by depth ratio which is recommended by the code is not satisfied. Then later on, I looked into the other limit state of collapse in flexure, and that is also not satisfied. So this clearly demonstrates the lack of basic knowledge on the part of the structural engineer who designed it. So to tell you honestly, I called the structural engineer who designed it. And I told him, and he admitted, sir, sorry, this is my fault. So then, see, I had to go for designing the retrofitting measures for this. I did it. I will not go for the details of this retrofit measures. So just I am giving you an idea. The span is too much. And having seen the detailed structural drawing, I decided to go for reducing the span. So how can I reduce the span? This is where the innovation in construction comes in. There, by seeing this one, that's why, you know, I tell my students also, you can go for innovative measures on a particular aspect only and only when you have the clear control over the basic knowledge required. So my advice here to my dear students, you give stress on understanding the fundamentals of the engineering. So here, see, I design on the basis of that. My fundamental concept I used here, I wanted to reduce, because I didn't want to dismantle the beam. I wanted to reduce the span so that the span to depth ratio is satisfied. So that basic concept, I designed the retrofit measures, and to do that, what I did, I drew some 2 cantilevers from the back. I will not go for the details, and gave 2 supports in the middle without post. The support was provided by cantilevers drawn from the back. So this is what, this shows the lack of basic knowledge on the part of the designer. The second one, you know, this is also a new building. I am referring to new buildings. So this was a building in which a staircase was built for a 3 or 4 story building for GOVT, Dibrugarh University. New building. And there also university didn't make any mistake. University engaged a consultant, qualified consultant, and they had their own supervising engineers. So university was not at fault. So here also, I saw, you know, this one. I'll take help of this one. Huh? See, I have shown it, I will not tell you. The staircase, that one sectional view, front view, and this was plan, second one, bottom one. On plan, I have shown a hatch area. Hatch area. Here, see, on the elevation, I have shown cracks in the middle. So that crack told me immediately when I saw the cracks. From the cracks, I understood that the supporting condition in this direction. Because supported in this direction, then only it deflected. When the shuttering was removed, it collapsed. Then I looked into the design drawings, and there the designer mistake, you know, he did not understand the supporting conditions properly. In construction, supporting conditions are given in this direction, and his main reinforcement he has provided in the direction of my hatch area. So this also clearly, there also, you know, I call the designer. I always do, that is a professional ethic. Whatever I have to tell the designer. That is a professional ethic. So I called the designer, and he agreed on the mistakes he made, and I advised the dismantling of the whole staircase and go for a new construction. See, nowadays, even for new construction, advanced techniques are being used. See, I have quoted in this slide some portion of IS 1893 Part 1, 2016, the latest revision. To control of loss of life and property, please, these are not my words, these are given in the code. Base isolation, other advanced techniques may be adopted. Currently, Indian standard is under formulation of design of such buildings, or such design, I'm sorry. Until the standard becomes available, specialist literature should be consulted. See, here, this concept, I'll give you a brief idea. See, structure, superstructure, the structure has got two parts, superstructure and the substructure. So during earthquake, what happens? Actually, the ground shakes. My superstructure doesn't shake. So on this concept, since the superstructure is connected to my substructures, when ground shakes, my superstructure goes like this. So there, based on this, what happened? Now this base isolation, this is the most modern thing. Only in a few buildings in India, this has been used. They have developed an element which is called the base isolator. It is put in the connection between the in the plane of connection between the superstructure and the substructure, so that when earthquake comes, ground moves, but my superstructure does not move. So that is being used. This is very costly at this stage, and a lot of expertise knowledge is required. This is being used in many countries extensively, but in India, it is coming now. Only in a few buildings, as far as my knowledge goes, it has been used. Mitigation, now this is all what I had to talk about today in relation to the mitigation measures to be taken for new structures. Now let me switch over to mitigation measures for existing structures. See, I am talking about now the mitigation measures to be taken in respect of vulnerable existing structures. The major aspects to be taken into account are vulnerability assessment. So for the existing structure, first thing, we have to go for vulnerability assessment. Then, depending on the findings of the vulnerability assessment, we have to design the retrofit measures. Then, retrofit measures are finalized, we have to go for working out the cost involved. And then, see, as a designer of the retrofit measures, I have the responsibility to justify the incurring of the cost involved in retrofit measures. I'll deal with that briefly in my next slides. So these are the four aspects, and I'll be briefly dealing with these four aspects. In the first one is the vulnerability assessment. So that assessment requires a lot of experience, knowledge, and all these. See, here the first point in respect of vulnerability assessment is to collect the architectural plans and structural drawings if available. See, in many of the existing buildings, you know, these drawings are not available. If these drawings are not available, then we have to go for preparing the as-built drawings by taking site measurements. And third one, from the drawings and visual survey. So I prepare the drawings and I go for observing each and every of the building. That is visual survey, to ascertain the type of structural system. So the major types of structural system we deal with are framed structure and masonry structures. The masonry structure are load-bearing structures. These are the system. Say I want to go for assessing the vulnerability assessment of this building. This aspect of what is the type of structural system of this building, whether it is a frame type or framed structure or a masonry structure. That is very important. The broad approach to the second part, I am under vulnerability assessment only. To conduct fourth point, we have to go for conducting a site survey for assessing condition of the existing structure. That is a detailed survey. Site survey, I mean detailed survey, which will include to conduct NDT test, to conduct laboratory tests for samples collected from geotechnical investigation, then prepare list of non-structural appendages. So what is non-structural appendages? If it is a framed structure, only through the elements of the frame load gets transferred to the foundation. So we provide other elements for functional necessity. For example, this is a framed structure. I designed it as a framed structure. So here I have put that wall. That is for functional necessity. I considered the contribution of that wall in the load carrying capacity. I'll come to that a bit later again. These are non-structural elements. They are called non-structural elements, which do not carry load when I design my structure. They are called non-structural elements. Then 6th point, a critical analysis of all the data collected from site survey, then the prepared drawings or available structural drawings or the result of the test, NDT test, soil investigation. We look into all these critically and identify where is the deficiency. That is very important. Therefore, analysis of the data collected is the most important part in the process of designing the retrofit measures. So here I have written a critical review of the non-structural elements that I have told you. Why that is required, I'll come to that. Now, once it is identified, critically analyzed, and location of the vulnerability is identified. There are two aspects of identifying the location of vulnerability in my structural elements. Some of them may be local and some may lead to the global failing of the structure. That understanding has to be there. Based on that, we have to prepare a mathematical model. And in the mathematical model, we fit our retrofit element. It is required. And after that, I am coming almost to the end of this. Analysis of the model is very important. That analysis has to be done by the methods recommended by the BIS code. There are a number of methods. Which method? Normally that model analysis by nonlinear analysis that is followed. And here see, I have noted that point. In the model analysis, one very important is ignored by many of the designers we have seen, the checking of drift limitation. So drift limitation, we have to understand what is a drift limitation, what is drift, and why the limitation is put by the different standards. These are I will not go for explaining those things. See, I am omitting answer to this question. What is drift? What is drift limitation? And third question, why is this required? So as a designer, we all have to understand this before you go for recommending, you go for designing a new structure or go for recommending a retrofit measures. So these limitations are given in our standards. Yesterday only I looked into BIS code I looked into one ACI code. So different countries have given different limitations. So once your model analysis has shown you satisfactory result, after you have fitted your units into your model, then if it doesn't satisfy, then you have to go for revising your model with optional retrofit units. And you have to go on doing it as long as your model analysis does not give you satisfactory satisfactory performance in respect of all limitations recommended by the BIS. So once this is done, I'll go quickly now. Time is probably here. So once it is done, then I go for working out the cost of retrofit. That is very important because see, I am going to incur some cost in an existing building. So being an owner, I would definitely like to consider the cost of retrofit in light of many parameters. So what are the broad aspect on the basis of which the cost, see, I have written one point here, I should not miss that. In working out the cost, since many students are listening to this presentation, we must be very clear about the basis on which we work out the cost. So here in retrofit measures, we go for item rate basis. For each item, we have to prepare a list of items which are involved in the implementation of my retrofit measures. So there to work out the cost, what basis I will consider? There, after seeing the list of items of works involved, I have to identify what are the items which are included in my standard schedule of rates. So for each location, there is a say for Assam, if I go for designing a retrofit measures, I'll have to consult the SOR for Assam, given by Assam PWD, like that for other places. And if there are items which are not there in the schedule, they are called the non-schedule items. And for those, we have got to go for rate analysis, looking into the market cost, labor cost, implementation, all those. Then I come to the last point, how to justify the retrofit measures. Whether the retrofit measures I have designed has to be implemented or not. That is the obvious question. If my client is a government will also ask that. If my client is a private owner, he will also ask. Because it is the owner who will be spending the money and he will definitely look into. See, justification has to be based on two aspects. One is, what are the benefits which will accrue on implementation of the retrofit measures? Second one, what is the, as a owner of the structure, I'll think, oh, shall I go for incurring this cost or shall I go for dismantling it and go for a new construction? That is replacement cost. Cost of new construction is called the replacement cost. So one has to consider both the aspects. So therefore, the justification is very important. Then what are the benefits on implementation of the retrofit measures will accrue? What is the first benefit? The first benefit is, it ensures I can sleep comfortably. Even in earthquake, you don't have to be in a hurry to go out. So that satisfaction will be there. Earthquake resistance will be there. It is ensured once properly designed retrofit measures are incorporated. Second one, ensures increased life of the structure. Once you incorporate the retrofit measures appropriately, you gain in life of the structure. The life of the structure will increase. And here now, final comparison. Comparison of cost of retrofit measures and the replacement cost. The owners always think, owner will think, oh, okay, my structure will become earthquake resistant once retrofit. But the cost I'll have to see, whether as a owner I'll think my decision as a owner, whether I'll go for implementation of the retrofit measures, or I will dismantle it, get it proper design and go for a new construction. And on that basis, final decision is made. See, I have written, as a general practice followed in many cases, the implementation of retrofit measures is considered if retrofit cost is within 50% of the replacement cost. This is a general rule. There is no rigid rule. However, there is no rigid rule. There is no rigid rule since the cost of retrofit has to be. No, I'll come to that. But these considerations apply in case of the buildings or heritage buildings of historical or cultural importance. Their comparison doesn't come because I have to retain that structure. Whatever cost is required, I'll have to go for incurring. But in case of this one, there is no rigid rule since the cost of retrofit has to be seen against the extent of increased life. That increased life you have to judge in light of the age of the existing structure. So I have given in red ink in my slide, judicious decision has to be made as to whether to go for retrofit measures or for replacement. The owner has a major role to play in this respect. So, yes, I have come to my concluding remarks. First one I have noted, as evident from the presentation, a clear concept of planning, design, and detailing of earthquake-resistant structure is required. That is very important. So I have noted this point particularly for the students. Second point, to develop this concept, one truly needs dedication, sincerity, and hard work, particularly in the scenario of fast developing technology relating to the methods, analysis, and design of earthquake-resistant structures. Third point I have noted, I am still a student of this field. I am still, oh, you are just budding. Now I am at the end of my life. Even then, I am a student. Why I am telling you no? 2 years, I have learned so much of different aspects of retrofit measures by being associated with projects. So, Doshi, you look back, I started my career in this way long back, as back as 71, 72. And here I have noted, while introducing, he told, my first international paper was published in 1977 in World Conference. And that paper was, you know, on the lateral stiffness of buildings. And you must note the importance of lateral stiffness. Then fourth one, the contribution of, here in the recent revision of the year, the research on this topic was started long back. I remember papers of 1960s. So in this same structure, I have this wall, these two columns beam. So when earthquake comes, lateral forces act on the building, and this wall contributes a lot in the resistance of the lateral force. But in our design methodologies, the contribution of that wall was not used And it is recently in 1962 revised earthquake where the contribution of this infill wall has been taken into account. Then last point I have written in conclusion, may I emphasize, very important for my students. In conclusion, may I emphasize that the students aspiring to work in the profession of structural engineering, you must develop the concept of structural engineering in your undergraduate course. You know what? Unless I know my undergraduate course, I cannot be a good designer. I cannot be a good supervising engineer. I cannot be a good project manager. Remember, my undergraduate course is so excellent. And if you ask me, sir, do you know the 10% of the undergraduate course? My answer will be no. I do not know how much percentage I know. So with this, thank you very much for listening to me. And if you have any question, I'll try to answer the question if any question is raised.
I'd like to thank Sir so much that he has given such a valuable insight to such an important topic, and this affects all our lives in some way or other. And as I have already mentioned in the earlier part of the session, that Sir is a very eminent personality and he has a lot of experience, be it teaching or be it, he has a total experience of more than 20 years in teaching and more than 30 years in this industrial construction. So his insight is a lot more valuable, and we should take all this very seriously and take our courses and in a serious manner, so that we can come up as few, as we are the future generations. We will be much more responsible for the construction of our nation, right? So I thank you, sir, and I would now like to request our principal, sir, HOD Civil Department, Dr. PK Pathak, sir, to please address the gathering and give the vote of thanks.
Good afternoon, everyone. So, all the participants here in this hall and online mode from different places of Northeastern region. More than 100 participants are there from various states right now. I thank all of you for participating in this session. I thank National Digital Library India organizer IIT Kharagpur for giving us this opportunity to conduct this session here from our department as a contribution to the NDLI. At the same time, I also thank our dear librarian, Mr. Sambartish, for taking all the troubles to smoothly conduct this session here. I thank my colleague Dipankar and Pinaki, and also Lakshmi ma'am for helping in every aspect. Now, of course, the premier thanks goes to our Dr. S.K. Barua sir. This one is, we are very lucky that we have a person among us who is from, who got his PhD degree in structures in a field which is still being studied, still being very much investigated and under research. And he got it from IIT Kharagpur, and we are organizing a session here under the auspices of IIT Kharagpur here by a person who got PhD from IIT Kharagpur. That is a very lucky thing for us, for our institute and for our department and for our students. What from this presentation, for my students here and those who have passed out and joined, and those who are not, they are in from your own place, they are joining here. What sir says is that first thing is we have to learn the basics before you go for anything, any innovation, anything, whatever our BTech course teaches us. fundamental things are there. We must know that before going for any further experiment on that, on the basics. Second thing is that here, when you approach a work like this, then how to approach this? Sir has given the presentation which we will be sharing with every one of you. That will be give you a scope for relearning. Moreover, here, this, for our engineers of this, particularly civil engineers of this region, we know that our region is a most vulnerable region for earthquake. It is zone 5. There are 4 zones now, 2, 3, 4, 5, zone 5. And we have different design criteria for structures, and which must be implemented, or which must be seriously studied and implemented while planning, designing, and executing and maintaining our structures, be it in building, bridge, be it in embankment, everywhere it is there. We must be prepared for the worst of the situations. And as our sir said, that Bureau of India Standards has taken lots of care to accommodate those things in their codes. The codes we must learn properly, codes of practice. Those who are in 4th semester, they will learn in next semesters, and those who have passed out, they already know all the codes there. Learning those things very carefully is very important. Okay, saying all this, I again thank Dr. S.K. Barua sir encouraging us, by saying that he is still a student. We are all students here, and we will be always students till we are here in this earth. And thank you so much. Hereby I conclude this one. Thank you. Welcome.